Hello, and welcome to this new session entitled CKA Exam Kubernetes Architecture. So in this session, what we're basically going to do is we're going to look at what makes an actual Kubernetes cluster from the master, control plane, and the worker node. So to start off, what I've done is, if you go first of all straight to our YouTube channel here, and if you click over here, you can see that there's an actual link to our GitHub repository. If you go into that GitHub repository here, you can see there's a Series 2 Kubernetes CKA exam. So everything that we study for this exam is going to be put into this folder here. So this folder is going to grow, but right now we've put the actual links of what is required here into Series 2.2. So what I can do is I can click into this here, and I can see that I have the full components here of what makes up an actual Kubernetes architectural diagram. So what I want to do then is I want to actually find that diagram to highlight, and understand where these components fit together. So when we're studying for any exam, we don't have to reinvent the wheel. If we search for Kubernetes architecture diagram, you'll find there's so many um, people that have already created these diagrams. So we don't have to, reinvent the wheel unless you really want to create your own diagram, and that's perfectly acceptable if you're doing this for work purposes. Um, but for our exam study, I found a good one here called Click IT, and Click IT provides a really nice diagram here. So if you kind of go into the architectural diagram website here, you can sort of see that in 2022, so it's quite up to date, it's quite relevant. Um, And if you click down, you know, down to here, you can sort of see this how Kubernetes fits together. You can see it talks about high availability, scalability, portability, security. Talks about the advantages of Kubernetes. Um, and when we go down, we can basically see that there is an actual Kubernetes architecture diagram here. So what I've done is I've put this into our repository here for our notes, which basically means that you know, anytime that we need to refer back. So as we're studying through these notes, we're going to refer back to this diagram. And it's going to make life really easy. But just remember that I did not create this. This has come from Click IT. I've put the link into the actual note, into the notes here. I've put the link down here. So I found the second one as well, the architectural diagram from Platform 9, which also has a good explanation of the components. But let's kind of get down into our notes now as part of our study. So we basically sort of said that, the worker nodes can load containers. They really do the work, and that's why they're called worker. Um, the master nodes, they manage, plan, schedule, and monitor nodes. It stores information related to these activities. And the control plane is the container orchestration layer that exposes the API and defines and deploys, manages the lifecycle of the containers. So there's a number of components that are starting here to work together. So if we go back to our architecture, we have a master node here and we have a worker node here. Now, the master node would really be the control plane in this case. So if you looked back at our session 1 of when we stood up our Kubernetes cluster on GCP or the Raspberry Pi, you could see that I also had called the control plane the master node. So you could look back at that video and you could see that that was certainly the case. But really for today, what you've got is all of these components working together. So you've got the master node to the worker node, and you could have a second worker node here. And these are your end users. So your end users are going over to your worker node. So as part of our exam, what we have to understand and um, learn is how these components work together. So let's look at the ECT cluster. So it's a key value format database. So it's basically just a key value pair. I've put a reference in here for the etcd database for the actual Kubernetes here. But you can certainly read much more about it here. But really right now, the database, and you can see here that they actually have it mentioned here, the key value store, which is really important, because what it's happening in here is it's relating and relaying information back to the API server, so that the API server can track all of these worker nodes and the activities, including the controller and the scheduler here. So that's a really important database. And what happens is, in the exam itself, you would be asked to um, probably back up this database and this key value store, and make sure that you can actually restore it, back it up. The next component that we want to go back to here is looking at the controller managers. So the controller managers manages all of the controllers for multiple components. So there's multiple controllers that are actually part of the Kubernetes cluster. So the controller, for the node, basically watches the nodes for changes like when they become unavailable. The replication controller makes sure that you have the correct number of replicas available. So what that essentially means is that, when you create a deployment, you have a number of replicas. So basically you say, give me 3 pods. In this case, I want 3 pods. And once when one of these pods, if one of these pods basically became corrupted, it would be replaced using the replica controller. So the replica controller is just making sure that, I've asked for 3 pods, and I do have 3 pods that are basically running. That's all the replica controller is responsible for. So if we're going to go down to the API server here, you can see this orchestrates operations in the cluster, exposes the Kubes API, which is used for management operations of the cluster. So this API is kind of like, pulling all the strings together. So this is the API server here, and it's pulling all of the strings together to make sure that the controller, the scheduler, the key value store, all of these components are all working in tandem together. So that's a really, really important component of the actual cluster itself. And then if we go down, we've got the schedulers, which, it decides on who should actually take the load. So the Kubernetes schedulers, they basically say, on this worker node, for example, depending on resources or depending on the availability of this worker node, so basically it's looking at the taints to make sure that, I'm not working on this worker node right now, and you can only schedule onto this worker right now. But basically what it's doing is it's saying, make sure that you can, at this worker node or this worker node, who is the best person to take this new load. So if from the master node, I had run a command here to say I want to have a new pod to be run, I'm basically sort of saying here, well, with the scheduler, who's the best person to take that load? Who's got the best resources, and who's going to do the best job performance-wise for that new pod? So that's essentially what the actual scheduler is doing. It's constantly just watching the resources and other items like taints and capacity and availability. So if we're going to go back here, we can sort of see there's also a cloud controller manager. Now, this is a new one really for me. I haven't stood up a cloud controller manager. I'm going to be honest. So this is something that, as part of the exam, what I believe here is obviously, as Kubernetes advances, you're going to have to make sure that you have some embedding into the actual cloud. So this is something that I'm going to have to really kind of understand a lot more. But I have put a link into it here about what the actual controller does, and it does sort of say that it's cloud specific control logic. As a cloud solutions architect, we really have to understand what that really essentially means. And I would like, at some stage to actually try this and sort of see if it actually integrates with GCP, with Azure, with AWS. And then we go down to our own container runtimes. And the container runtimes are essentially very, very important, because if you look at what actually a container runtime does, you need to install a container runtime into each node in the cluster so that the pods can run there. So there's multiple container runtimes, but basically, essentially, what the container runtime is doing is it's making sure that all this works together. Now, in this diagram here by ClickIT, they have container runtime of Docker, and that's perfectly acceptable. But in the past few 2 years possibly, what they've done is they've moved Kubernetes itself has moved away from Docker. Um, so you know, just be aware that the actual Docker runtime has stopped being supported now in the version since 1.24, and the exam itself, if you go back to our exam notes here, you can see that I've put in the curriculum here of 1.26 here. So 1.26 is what the exam is, and it's saying here um, on the container runtimes that the Docker has essentially been retired out of the Kubernetes from 1.24. So it's just something to bear in mind. But as you look through the documentation here, and I can see I'm in container runtimes here. I want to highlight something that the Kubernetes documentation is fantastic. You really do learn an awful lot. So what I would suggest is read through each of these pages here and try to understand as much as possible, and relate back it, to your actual diagram here, and make sure that you do understand what's actually being discussed here. But going back to the container runtimes here, you can sort of see this container D, and if you saw one of our previous sessions, with the Raspberry Pi or with GCP, we also use container D. But there is alternatives out there that other people use. So um, let's kind of go back to where we're saying here. So that kind of covers our our diagram here from a kind of master node here, and then we kind of like look a little bit more into the actual worker node here. So with the worker node, because you've got to remember, you've got a master node, which is your control plane here, and you've got your worker node. So your worker is doing the actual work of running the actual pods themselves. The master node is really, pulling the strings to make sure that everything works together, but the worker node is doing the actual work itself. So what I want to do here is I want to go back here and I want to go down to my notes here and I want to say, okay, what's a kubelet? So it says it listens for instructions from API server and manages containers and logs, periodically fetches information from these as status reports. So I also have a note here, kubeadmin does not deploy kubelets. It always has to be installed. So when you actually stand up your Kubernetes environment, you know, as the notes sort of say there, your kubeadmin does not get your kubelet installed. But what I would be saying is for the exam, learn about what the actual kubelet here is. So it listens for instructions and manages containers and logs, etc. So that's what the actual kubelet does here, because you can see that they have a beautiful link here from the API server over to the kubelet. So here I can grab from a kubelet, and this is for non-kubeadmin. Okay, so you can actually see the running processes on the master node here if you grep for the kubelet. But this is for non-kubeadmin. So kubeadmin does not install. When you use kubeadmin, it does not install the kubelet, but you certainly need to understand and learn about it. The kubeproxy here enables communications and services in the cluster using internal pod network. So basically it uses rules. So the kubeproxy, if you look here, let's see if we've got a kubeproxy. We have it over here as a network proxy, but essentially it's doing the same thing. So it's essentially using the rules, IP tables, to make sure that there's communication of the pods within the actual cluster. So that's essentially what the kube proxy is actually doing. It's doing all of the networking side, so it may be referred to as network proxy. They've also put in, in brackets here, the kube proxy part. So as we get into looking at the deployments themselves, you basically sort of see that, all of the actual pods have networking, they have internal networking. And that also, will be tested in the exam, because you have to understand that when you create any type of new pod, it should be connected to your actual cluster, and how to verify and maybe, use tools such as curl or other types of diagnostics tools to make sure that, you don't have an issue with just one pod. So going down finally then to the, this is just a repeat of what we saw with the container D here. So essentially that's the worker node components here. And again, what I'm going to be doing is as I work through these notes, what I'm going to be doing is I'm going to be making sure that, I'm fitting all of these items together. What I've just shown today, make sure that you read through the Kubernetes documentation, make sure you understand. And again, the Kubernetes documentation here, if you click into it, you can actually have this documentation open. So learn about the documentation, learn and understand where all of these actual components are and how to find them quickly, so that when you're in the exam under time pressure, you can find the information that you need to hand. So that's a quick run through of the actual Kubernetes architecture. I'll see you in the next session. Thank you.